My guest today is Kurt Streutker.
I was a school teacher for 25 years. I taught science primarily. My focus in studying college area was geology. I came to love geology because of the Ice Age. I live in a very volcanic area here in Sonoma County, and there was Mount St. Helena, which is a volcano that blew up about 4,000 years ago and just left us devastated with a landscape that was, I call it, a volcanic debris field. There's rocks, boulders everywhere. You step over anything around this area, there's Annandale State Park and so forth. And so there's rocks and boulders everywhere. And then a great event took place called Mount St. Helens, May 18th, 1980. We have this amazing event that was one of the biggest geologic events that we saw in recorded history insofar as like video was concerned. So when Mount St. Helens blew up, it sent a cloud of ash to Maine in less than 3 days. This whole plume of you probably remember it May 18th, if a lot of people who were old enough. And if not, look at the videos. It's an amazing thing. But what happened was it started altering the weather as well. And that wasn't my focus then. It was more like, my stuff was more like the geology that you see behind you there, you know, the layering of rocks and so forth. But then as I started studying, this whole thing is this climate change nonsense. Now, let me just say in the outset, no one you know believes in climate change more than me. I believe in climate change more than Al Gore and Bill Nye put together. Matter of fact, they're virtual climate change deniers compared to me. I believe in it so much. So what I mean by that is this: climate change is real. The thing is, it's not caused by humans. It's not driven by carbon dioxide. You know, to get an ice age, which I'm going to get into in a moment, you know, you need to have warm oceans and cold continents. You have to have both at the same time. The Earth doesn't start cooling all equi amount the whole bit. It's to have a ice age, you need warm oceans to get the water out, cold continents to trap it and keep it there. And so we've had ice ages. And so my dissertation, specifically, I worked on how Hawaii was critical in the Great Ice Age, because underneath the ocean, there in the middle Pacific Ocean, there's no faults down there, but there's volcanoes. And these volcanoes, you know, Mauna Loa, Kilauea, Mauna Kea, they form this massive volcano or this island called Hawaii. It's 33,000 feet from the bottom of the ocean. Bigger, much taller than Mount Everest. From the bottom of the ocean to the top is 33,000 feet. Mount Everest is 29,028 feet. So we have this idea here that was massive uplifts. We know that with Mount Everest. We have, fossils on the top of Mount Everest. Okay, we have layers of rock that are oceanic. So it came up from underneath. But my point of this is Hawaii is all magma, all this volcanic. So what I did my work on, working with different fellows like John Baumgartner and different fellows at the Sandia National Laboratory in Los Alamos, they kind of got me going on this whole trek of studying how the Ice Age took place, and then possibly how Hawaii provided that warm ocean. You see, from the bottom of the ocean to the top, you have this, volcano that now it's just shield volcano, goes way down. And when that was forming, it caught a lot of steam, because when water comes in contact with magma, we have massive amounts of pillow lava and steam. So you have tons of it. Remember back in 2017, I think it was, I was watching Hawaii very closely tectonically, because there's volcanoes going off. And of course, there was magma in fissures everywhere. And it was going down to the oceans in massive amounts, plumes of steam when it hit the water. Imagine the magma coming in contact with the ocean bottom and coming in contact with the water that was over the ocean at that time. Massive amounts of steam plumes coming up, and that steam flows. The prevailing winds go from Hawaii to the West Coast. That's how we got they call it the cyclone bomb. When you have these oceanic currents they talk about, it's actually called the Pineapple Express, but it doesn't sound near as threatening as, oh no, it's the cyclone bomb. So we have the cyclone bomb coming in and dropping, billions of gallons of water. Now we have all of our reservoirs, Shasta's full, Sonoma's full, all these different reservoirs. A lot of them are letting water out as fast as they can because they have so much of it, because these cycles happen. So like I said, getting back to Hawaii now, we have this steam going over the continents. Now, if you had a meteorite or meteor strike that possibly caused, we can't prove this because no one was there to see it, but we see, geology is the forensic study of the past. You look at the crime scene, we see moraines, with ice ages. We see scraping a rock, dragging across, in these different areas of our great fruited plain. So these things leave tons of evidence. But see, the thing is that just like a lot of bad science, it survives on basically censorship. It says, no, you cannot question this. And the man-made or anthropogenic, as I like to say, global warming, climate change myth survives only because of the censorship that is prolific right now with regards to the protecting the bad science from actual scrutiny. The scrutiny is omitted, and that's the problem with the whole thing with climate change or man-made global warming. Like I say, I believe in climate change, global warming more than anyone you know. Even Tony Heller would probably be right up there with me, and a bunch of the other great guys you've interviewed, by the way. It's just an honor to be with on the same platform, I tell you. But my point is this: to have an ice age, you need warm oceans, cold continents. So if a meteor strike hit, there would be an equal and opposite reaction in the Earth. And that's why we see Mount Lassen, Mount Shasta, Mount Rainier, Mount Baker, Mount St. Helens. The one that's down the street from us here is Mount St. Helena. Mount St. Helena blew up. It's half as tall as it used to be. It's actually like a Mount St. Helens, and it just left debris everywhere. Igneous rock is all over the place out here. But then, of course, the biology goes over and you can't see it as well. But, since I like geology, I kind of have to look past the biology on the surface to look down at the rocks, So this whole thing, when you get a volcanic blast of on the mainland now, on America, let's say, and you have Rainier, Shasta, Baker, Lassen, all these guys going up, then that cloud of ash goes over the continent. Now, when you block the sun is how you get an ice age. You have to get rid of the sun. The sun warms the earth incredibly well. Look how hot it gets when you have a nice summertime. In 1936, we had some major heat waves and people were dying. And it was primarily because there's basically air conditioning that was keeping people cool enough. So you had the Dust Bowl, we had people, struggling. But of course, all this data has been omitted. Oh no, it's never been as hot as it was last year because it's progressively getting warmer and warmer. The hockey stick, the nonsense of the hockey stick. Now that guy there is a piece of work, I'll tell you. Michael Mann, who gave us hockey stick. What terrible science. Yes.
So before you go on, what do you think caused the heat in the U.S. in 1936?
Well, we had these natural cycles. And 1936, for some reason, there was just a lot of heat. Now, if I did more research for our interview, I would have probably come up with a better answer for that. But a lot of times we have what we call solar flares, black spots, sun. Right now, we're in a solar minimum. If you have a solar maximum, sunspots and solar flares, you're going to get a hotter sun. And then, of course, weather is so dynamic. It's, carbon dioxide, as they say, as Soon says, it's not a knob that controls the weather. We contribute so little carbon dioxide to our environment, which I'll talk about a bit. But the carbon dioxide is not the thermostat that drives the climate. That is utter and complete nonsense. It is so much more dynamic than just a little carbon dioxide or a teeny little bit of methane, which is nonsensical because we measure methane in parts per billion. It's not even a factor. They can argue, well, carbon dioxide holds heat. Well, sure it does. And it's a greenhouse gas. But, I would say, what is the number one greenhouse gas? It's water vapor. 95% of the world's greenhouse gas is water vapor. A tiny little bit is carbon dioxide. Now, the problem is with carbon dioxide, it primarily holds heat during the day when the sun is touching it. Now, listen to this. This is actually a critical little point here. Water vapor, you go to Hawaii. Why? Because you go there for the great palm trees, the coconuts, the mai tais, whatever, whatever you want to drink there, tropical. But at nighttime, it's much nicer. I used to live in Hawaii for a while, and I would sleep out under the stars, and I'd look up at this beautiful creation, and I look at the palm trees and I look at the stars. But I'd be up all night, not even wearing a blanket. Now, could I do that here in California? More than likely not. And the more inland you get some radiant heat because the earth does grab the heat, hold it because there's that let off. But here's the thing. This is another. I'm kind of going everywhere, but the point is, when there's a solar eclipse back in 2017, it went from Salem, Oregon, all the way across America, and it hit all these states. A friend of mine was up in Colorado, and he was saying there, yeah, Kurt, it was 80 degrees outside, and there comes the moon is blocking the sun. We saw the shadow it cast. It was amazing. And then he was in a t-shirt, and he says, man, it was great. It was t-shirt weather. And we're looking up, we got our glasses on, and all of a sudden it dropped in temperature like that. It went from 80 degrees to 65 degrees in seconds. So within 10 seconds, he says, man, let's get a jacket. They weren't ready for the snap of cold. And see, when you block the sun, that's what happens. You can see that in the Midwest a lot of times. I used to work out there a while, and a big cloud comes over, and all of a sudden, next thing you know, it's like, wow, it dropped in temperature a few degrees. It's noticeable, right? And that's the clouds. And see, the clouds are amazing because they influence weather far more than you can imagine because they block the sun. So as you get an El Nino and you get lots of clouds over the Pacific Ocean, the sun hits that, and some of it's absorbed. Okay, it does what it does, but some of it also reflects off because it's white. If you ever fly from California to Hawaii, and during an El Nino, you see nothing but clouds down there. You say, where's the ocean? It's like all they see is clouds all the time. So depending on the time of year, the weather, the tilt of the earth, all these things are factors that contribute to our climate and our weather. And so also bear in mind that in the summertime here in North America, when I was in Australia, that's obviously south, we're closer to the sun. We're not in a perfect equidistant from the sun at all time. We're a little closer sun, we're a little further, we're elliptical orbit. So a little closer, it's like if you had a campfire and I'm sitting here and I'm way back here, and it's like, okay, well, let's see here. The weather's great. I mean, the heat's nice. But if I go back a little further, hey, wait, let me get back here. It's a little cold back there because it's nighttime here in California. And then you say, okay, now this is the right happy spot. And then if you scooch a little closer, it's like, whoa, stop. My face is catching on fire, right? So you want to be in that anthropic zone. Silly people call it the Goldilocks zone, kind of want to cater to the kids. But the point is this, it's the anthropic zone where man thrives in this bit here. So a little closer to the sun, not too good. You get too much steam, no ice. A little further out, you get too much ice, no steam, but we're in here. But we're not fixed. We're in this anthropic zone. So life is possible and thrives in that bit. But too close, we're going to be, ending up like Venus. A little too far, man, we're going to be cold, a little colder than we like. So we're in this little bit here. Yes.
I have just a question I'd like to throw in that came in via direct message a day or two ago. Can we get an analysis of the fact that CO2 must provide the primary mechanism of cooling under a full eclipse in calm, dry air? Further, the air cooled under such a full eclipse amounts to trillions of cubic meters of air shedding an order of 10 to the 12th kilojoules to space. Neither surrounding air nor the surface warms in just a few minutes. I think we could use that data measured during full eclipses to prove that CO2 cools the planet and some bounds on how much CO2 cools the planet under clear skies. Any comment? Does that make any sense to you, or what do you think?
It made pretty good sense. I'm going to try to handle that this way. With regard to that question, CO2, does it cool the planet? Well, it's a greenhouse gas, but remember, it only holds heat during the day. So when you block the sun can't come in contact with those three little molecules. And then all of a sudden, once the sun stops hitting it, they remain still. And when the sun hits it, no sun at night, obviously, when the sun is taken off, it stops holding heat. And it only holds heat for seconds. It's not like holds it for a long time. For example, with the eclipse. The eclipse, when it comes over, it blocks the sun completely. Nothing gets past the moon, right? So you're in the complete shadow. So it's an abrupt cooling that happens quickly. So carbon dioxide, yeah, it holds heat during the day, but at night it doesn't. And it doesn't hold heat that effectively. The one that holds heat the most, obviously, is water vapor, which is the chief and number one by a ton, better at holding heat all day and into the night. That's why it's much warmer at night in Hawaii, whereas here it's not that warm. So those are some big numbers that your fellow brought out there. But the idea that, I'm kind of a laymanizer. I laymanize things for the average Joe. I taught school for 25 years. I'm not talking to PhD scientists at Harvard or Princeton or MIT. I'm not Lindzen. And so, yeah, I'd like to study under those guys. But at the same time, I think, okay, so I have to take this information, boil it down, and red pill people with it. This is something cheeky. All right, I'm going to show you this. I can't help but do this. This is 2,500 pennies here. And I keep this in my car. If you can see that there, it says carbon dioxide levels are currently at 400 parts per million. That's 400 over 1 million. That'd be 1 over 2,500. So I have 2,500 pennies here. This penny right here, that penny there would represent all the carbon dioxide if this was all of the atmosphere. So this $2,500 or $25 worth of pennies, 2,500 pennies, that one penny is the carbon dioxide. And I kind of put that in people's lap and go, here, hold that. And they go, that thing's heavy. It's like 15 pounds. And I say, yeah. And we only contribute 4% of that penny. We contribute so little. And I do little talks on these things. I'm doing I've done some radio interviews, obviously, and I do talks around the area, and I did them back in Australia and so forth. And that thing right there, they call it my little handy little red pill. So I recommend all those people out there who are doing climate debates on showing that people don't have to believe in man-made global warming to be a scientist. You have to believe in global warming because we can observe that, repeatable, observable, testable in the present. But that's thermodynamic nonsense. I tell people, say, well, be like me lighting a match over here and catching that guy's hair on fire. This is not enough flame. If I had a flamethrower, yeah, we got plenty. But if I light a match and it burns, and they don't even feel the heat, it doesn't burn his hair off. So thermodynamic nonsense is what we see with the whole climate change, man-made. I have to make sure people know I believe in climate change more than you, but I believe that man-made climate change is nonsense because it doesn't even fit the science. So with regards to the ice ages, now that's kind of my little end because that's kind of my specialty and so forth. So I get in there, I talk to people. It's kind of like the wedge. I talked to a lady the other day, and she says, "Oh, you're going to be doing a talk on what?" I'll be doing a talk on, the ice ages. And she says, "Oh, really? What about the ice ages?" Well, did you know that to have an ice age, you need warm oceans and cold continents? Well, if you can, like I was saying, if you have a meteor strike causing the magma to create massive amounts of steam in the ocean, which Hawaii had to have been formed when there was water, over it, and it popped out. Remember, it's 33,000 feet, where Mount Everest is much smaller. So it's much bigger. So it's massive amount of oceanic water was taken out energetically and blown over the continents. Now we got to trap it. How do you trap it? Well, you block the sun. So you have all those volcanoes, those stratovolcanoes here in North America, for example, Shasta, Rainier, Lassen, and so forth, Baker. All those wonderful places I like to go to and see. Mount St. Helens up there and Mount St. Helena down here. And my point is this. Now you block the sun, because May 18th, 1980, when Mount St. Helens blew, it sent a cloud of ash all the way to Maine in less than 3 days. And then what happened there was it was dark. Streetlights were on 24/7 and the temperature dropped. And that's the critical thing. So if you have all these, volcanoes going up, going crazy, the ash plumes go across, blocking the sun. You block it long enough, you're going to have an ice age. And Mount Pinatubo, when it blew, it affected climate. When Greenland, it had its bit, I should say Iceland, when it blew up, that's a big volcano. It's like a Hawaii, but much bigger. And it blew. And it caused, all kinds of problems with the climate because these things are influential. Carbon dioxide is a non-player when it comes to the climate. Yeah, it's great during the day and plants love it. It's plant food, but it's definitely not something driving climate, especially our small contribution.
Can you describe the process? A meteor can cause volcanic activity. And is that could it be years away or thousands of miles away from where the meteor struck?
Well, let's say this. Every action is an equal and opposite reaction. So the Earth is totally connected. The oceans, like if you have a meteor strike at the oceans, you have a tsunami. You have all kinds of things happening. But so when meteors hit the Earth, sometimes they thud, sometimes they burn out, sometimes they go thud really deep, and sometimes they go thud deep into the magma or into the actual mantle. And that would cause a bleeder. It's like I took a little spitball and hit somebody with it, that would just get them mad, But if I got a bullet and go bang, it goes into them. Now they got a bleeder. So what the meteor that could have created the hot spot in the middle of our Pacific Ocean would have caused an equal and opposite. See, they're all connected. So it would turn up the volume, might say, or turn up the tectonics of the West Coast, particularly because those are all, we have strike slips and then convergent. We don't have any divergent faults. We have convergent where they come together. That's why you see, faults when they hit, boom, and they hit like that, and all see the push, converge, bam, and then it sends a nice tsunami, and it takes out. Remember in it was I think 2001, we had a tsunami that went over Indian Ocean, and there's all those convergent faults. One of them, bam, like that, and it just sent tsunami. And then there's a couple of them, obviously. And then, of course, with Fukushima, right in front of Japan, convergent faults. Well, in our area, we have strike slip, so they slide. And up in, say, Oregon, Washington, there's a convergent one up there too. So they come together. So you got convergent, divergent pulling apart, and boom. Now, the Mid-Atlantic Ridge is divergent primarily. Okay, you got some strike slip in there too, obviously. But they converge. They diverge, they pull apart. That's why we get Iceland. That's how we get, the Mid-Atlantic Ridge, from the plate tectonics and so forth, which I'd love to get into that too, but we're not talking about that today. We're talking about anthropogenic global nonsense. Okay. So one of the things I like to bring up with regards to the Ice Age too, is that, it was primarily driven by water vapor and the sun. Okay, so we have to cool the sun, i.e. not cool the sun, but block the sun. We do that with the volcanic ash in the atmosphere, but the water vapor. And so water vapor, gives us clouds. Clouds are a massive influence over our climate. It cools the earth, okay? Clouds cool the earth. They bring water, they reflect the sun, and they hold heat all at the same time. So, when it's a clear night, when I was living in Australia and I was telling my mates out there, I said, look, it's a beautiful night out tonight. He says, hey, mate, it's pretty cold out here. I said, well, because there's no clouds holding the heat. I was over in Sydney and it was a beautiful night, but it got cold. And it's not as cold as other parts. Like I was in Perth, and that's more West Coast climate. And so you get a different climate zones there. So in other words, climate is so dynamic. It's just not one little knob that controls. Oh, wait. We're having too much carbon dioxide in the atmosphere. We're kicking out 4% humans contribute 4 to 5%, and that's being generous, of a carbon dioxide. But wait, plants love it. It holds heat for seconds, doesn't contribute to weather changes much at all, if any. It's not the knob, and our bit doesn't contribute anything. It's like saying that methane, which is 1 out of 500,000. So if you have 500,000 pieces of atmosphere floating around out here, boom, what do you got? A little methane in there. Boy, he's holding heat a long time, isn't he? He's contributing to climate change. Absolutely nonsense. That's complete rubbish, as they say in Australia, mate. So anyway, the idea that we have this whole planet that is influenced by just that little bitty molecule is utter rubbish and nonsense. And so red pilling people and saying, look, here's the ice age, here's how climate changes, because we had radical change. I mean, we found mastodons, roaming the earth, and all of a sudden they were munching out, and then they ended up dying. How they die? Die of old age? Did they get eaten by scavengers? No, they froze in their tracks with food in their gullet and in their mouth. They had, they could actually find, you've heard about that perhaps, right?
I have heard about that.
Yeah. That sort of thing right there says, maybe we should think about how climate changes quickly too. When you block the sun, solar eclipse, it dropped 15 degrees like that. But the moon passes pretty quick. It wasn't there for days. It wasn't there for, even hours. It was there for minutes, as the moon kept moving across. So what do we come to? We have to look at climate as a dynamic thing. There's tilt of the earth, just a little tilt away from the sun. We get a winter time that you can't believe. Wow, look at all that snow. Then if we're over here And we get the sun coming this way. Wow, it's baking us. It's like, and that's just the elliptical orbit around the sun with our tilt at 23 roughly degrees. So all these are factors. That's just one factor. They kept factor in the clouds, factor in the solar minimum, solar maximums, factor in the sunspots, factor in the solar flares, factor in the amount of water coming out of the oceans during an El Nino. That's how we got so much water here in California. Well, we got too much. Wait, we had a drought last year. Yeah, and what's your point? You look at tree rings, dendrology, what do you see? Well, we have this great little thing, this display here. Look at California's history in a tree. So they have this tree, have the rings and say, right here was the gold rush, and right here was this, and right here was that. And they have these little epics of time. And this is what the tree was doing growing out. Well, if those are kind of cool, but when you look at it deeper, you look at the tree rings are more, smaller during the drought seasons, and they're bigger during the not drought season or the plentiful times. So we see cycles through California history, through our redwood trees and so forth. So the claims that they're making is political. I mean, our government spent, we're spending like $6-7 billion a year on average before this nonsensical thing coming on. It's called the Biden administration. Says, hey, we have to save the world from climate change. Let's spend $300 billion. That'll do it. It's like, throw money at that's a crazy thing. That's a political thing to do. Who's making money on it? Well, my crony friends are here and there. Well, of course they are. And what are they doing? They're donating the money back to us. So we spent $300 billion. A lot of it comes back to the party of choice, which is mostly Democrat at this point, which is controlling our presidency. $300 billion, utter nonsense. It's political, it's money driven, it's greed, and it's censorship that's driving this whole hoax. And then you have John Kerry out there flying around the world in his jet. Well, you see, I'm so important, I have to fly. I can't fly commercial. That's for losers. I fly private because I deserve it. And I'm saving you from climate change. That's the ideas of these people are complete nonsense. The science of climate change is all about thermodynamics. It's not about carbon dioxide. For example, you can see in this little graph here, you have oxygen and nitrogen. This is kind of a red pill moment for some people. I show these people these graphs sometimes to say, Earth's atmosphere is composed of, I ask people all the time, I say, how much carbon dioxide is the atmosphere? I asked a person just the other day, a lot. Well, give me a percentage, like 21% oxygen happens to be correct. And they say, 60%. I say, well, not even close. It was funny that I talked to this one layman. He was doing smog tests for my car. We do smog tests here for my other car, which is a gas-driven car, petrol. And he said, oh, yeah, it's about 400 parts per million. I go, really? Wow, you're pretty smart. He says, well, I do smogs. I know about atmosphere. But 90%, 99% of the people I talk to have no clue. So 21% oxygen, 78% nitrogen. So 21 and 78, about 99%, right? Well, what's left? 1%. So is that how much? Is that the carbon dioxide? Not even close. The next biggest gas is argon. 93% of the 1%, which is most all of it, is argon. There's trace gases. And I say, look at methane, 0.00030, 1%, 0.0001% methane. That's 500 parts, that's out of 1 million, that's parts per million. That would be 2 little molecules floating around. And that's, how it goes. Carbon dioxide, 0.038%. Let's just run it to 400. 400 parts per million. That's 1 out of 2,500. One little molecule of 2,500 molecules is not driving the climate. The number one greenhouse gas that holds heat is water vapor. And they go, yeah. Then I say, look here, we have nitrogen, oxygen, water vapors is 4%. It depends on where you are on the planet, because you have deserts that are dry, like places where you could freeze to death in the middle of the desert too, because it doesn't hold heat. But you're not going to freeze to death on the tropics, because the tropics hold the heat because it holds the water vapor, creates the water vapor. Hawaii, those places like that. And so the dynamics is that God has given us this great planet, and now we have water flowing up north. We have water catching these winds. We have the Pineapple Express giving us so much water we don't know what to do with. And then we'll have another drought, and then we'll have some more water. In 2017, we were letting water out of a dam called Oroville. Lake or Oroville Lake or whatever dam. They said, "Hey, it's going to go overflowing. We can't have that. Let the water out." This is kind of interesting. This is tectonic stuff and dealing with geology. There was a dam. You might have heard it was Hoover Dam. It was overflowing. Let the water out. And it's a lot of water they had to let out. And a thing called cavitation takes place. When you have rapidly flowing water through a tube, let's say, or wrapping through a canyon, it starts cavitating. And that's like, bazillions of jackhammer going through and blasting out. So what happened, we can look this up, it's interesting, that they opened up the, after they, like this earthquake going through the water, rapidly flowing water, just ripped a massive hole and made it much bigger. And there's rebar, and they're watching all this cement flying out, into the big, as the water's let out, the dams is flowing out, because they're going to, there's going to be a problem if it overflowed. So they had to let the water out, but rapidly flowing water does this cavitation. That's a quick side note there for you geologist fans. But, and like I said, we could talk more about geology later, but this topic of anthropogenic global warming or real climate change and real global warming has to do with how there's fluctuation of water coming and going on our planet because of different seasons and because of different, epochs, or what we call is just climate change in general. I mean, we've had how many ice ages? We had the Great Ice Age, but then we also had the Roman War, right after the Great Ice Age, we had a warming period. And then we had a time where it got cold. And during the Grecian Empire, did you notice that they didn't go north? They went east to the Babylon and those places. Alexander the Great went east. He didn't go north. When the Roman warming period came, though, right after the Greeks, we had a warming time where Rome went as far north as the Danube River up top there. They went to England, and they grew grapes in England as far north as Scotland. Come on. That's climate change. That's amazing. They were thriving. The earth was a much better place at the time. So my point is this. You have the Great Ice Age, where you had mastodons frozen in their tracks. Then you had a warming period. We're interglacial. And then we have another cooling time. And then we had another warming period. It would be the Roman warming period. Then we had another mini ice age. They call it, there's 2 mini ice ages. And then we come out of that, and we're coming out of that. We have the medieval warming period, where Greenland was green. How do you get it? Anything got its name? These people out there, look at this place. It's covered with ice. It's all white. Let's call it Greenland. How stupid is that? No, it was green because we can grow our crops there, mate. Or they don't say mate there. They say something else. There's Danes. It says we can grow some crops, and most importantly, we can grow some hops, and we can have some beer so we can cope with the crazy world we're in. So Greenland became a place where the Danes came to settle and so forth. But then another ice age came and ran them out. There was an amazing little event that took place in World War II. So P-38s, I believe it was. They crash landed. They called it the, they crash landed it, and they escaped. They survived, but they left the planes there. And that was during World War II. They came back. There was 75 meters of ice that buried them. I don't know if you heard about it.
I did.
It's called the Lost Squadron. And it shows you how quickly ice can pile up. And that's not just fluffy snow. It's compacted snow. And so just in, 70, 80 years or whatever it was, you had a massive amount of snow that piled up. And they actually drilled a core down there, and they got it. And they took it apart, and they brought it up and reassembled it. They called it Glacier Girl, because she survived the glacier. No one's flying it, I believe, but they pulled it up. So you can look up the Lost Squadron, they called it, in ice of Greenland. And it shows how quickly these things change. So my red pill here for this slide would be this. Methane is if you think methane is driving climate and you should eat bugs, well, you need to eat bugs to save the world from anthropogenic global warming, because your fault. Think again, because that's utter and complete thermodynamic nonsense. And they even one up on that one. It's not the most nonsensical thing. Carbon dioxide, greenhouse gas. Yeah. But what is carbon dioxide's primary job? To make sure plants are green, because we have photosynthesis, we have water, we have the sunlight. Well, we need something else here. What was that again? Oh, carbon dioxide. That's right. So you have these 3 things for plants. Now, plants have these little stomatas under the leaves, and what they do is they absorb carbon dioxide. Now, this is an interesting factoid. When I was over in Switzerland, I was noticing there's greenhouses everywhere, and I was staying at a house. There's looking at a field of greenhouses. They're growing food all year round. So I asked my friends there, and I said, is this a common thing here? Oh yeah, Switzerland, we're very, very efficient. I was on a train one time, and I said, how much time till we get to the next station? And the guy looked at the conductor, goes, 14 minutes. And he was looking at a sweep hand, right? 14 minutes. These guys are so precise. They tell time based on the trains. If you say the train's going to leave the station at 5 o'clock, it's leaving at 5 o'clock. It's not going to wait a second longer. That's how crazy they are. So these wonderful people, the Swiss, they have these greenhouses, and one of their tricks of the trade is, well, we got the sun, we got the water, we need carbon dioxide to accelerate the growth. So what happens is they accelerate the growth by what? Adding carbon dioxide, which gets a quicker crop, a bigger crop, and they use, guess what? Less water, because the stomata aren't out there struggling to receive that precious elixir of carbon dioxide. There's so much they can take it in. They close the stomata, and since the stomatas are closed, guess what? They don't transpirate and lose water. So they use less water. So plants become more drought resistant when there's more carbon dioxide. And so it doesn't drive climate whatsoever, but guess what? It makes plants thrive. And the greening of the earth, you interviewed Patrick, the founder of Greenpeace.
Patrick Moore.
Yeah. And he's saying we have a carbon dioxide dearth. You interviewed Happer, William Happer. He says, well, we could use a little bit more carbon dioxide. It makes the world a little nicer. He's Mr. Nice Guy in there, but he's absolutely right. Our planet thrives under more carbon dioxide. During the Roman warming period and the medieval warming period, life was good. Glaciers weren't melting and flooding places out. I mean, after the Great Ice Age, the Aborigines in Australia now, get this, they talk about out there where the Great Barrier Reef is now, that was dry land. Well, how did the Aborigines get to Australia? Did they swim? They boats? No, they walked, just like the kangaroos hopped and the koalas waddled and made their way across or whatever. The land bridges during the Great Ice Age, that was warmer. Remember, Australia the top part is tropical, okay? So you have water stacked up on the continent, say North America, Siberia, just tons of ice. We're talking, remember, in the Great Ice Age, we had 2 miles deep here just in the West Coast. Yosemite Valley had a little over 9,000 feet of ice. In the Midwest, Detroit land, Chicago land, all that area, we know that there was at least a mile deep. Well, that water came from somewhere. It was brought in by the sun and trapped because it was blocked. So we moved it out of the ocean and onto the land and trapped it because we blocked the sun during the Great Ice Age. So that's where these land bridges came. So Australia was populated primarily during that Great Ice Age, where the Aborigines made it down there. And then, of course, the water rose after the Great Ice Age, and things have become actually quite stable. This is one of the most stable times in Earth history. So here I am at Bondi Beach, my favorite beach in Australia, mate. And so I took a picture there, and I should have said, thanks, Tony. You're a great guy, because he gave me these pictures here. Bondi Beach in 1989. There's a nice young lady there standing right where I'm standing. And then there's a nice little lady with a little bit less scantily clad, more of a Victorian, 1909, looking at Bondi Beach, my favorite beach in Australia. And there's a picture of 1889, Bondi Beach, before it even was inhabited. My point is this, with this particular slide here, there I am. Look at behind me, though. The oceans haven't changed a lot. Have you noticed from 1800? As a matter of fact, most of global warming of this last epoch, of this era of interglacial, has been before most of our cars and industry. We had a lot more, and they don't like to bring that up. They despise history, these climate change enthusiasts. And I'm a climate change skeptic when it comes to what fools say, because when they're making up stuff and hiding information, see, they don't want anyone to know the truth. They want you to think that they have all the knowledge, but certainly they do not. They say, no, you cannot question it. It's a settled science. Hello, wait a second. I taught science for 25 years. Science is repeatable, observable, testable, and falsifiable. What if we used our technology back in the 1800s of medicine? Where would we be today? We'd be putting leeches on our necks. Oh, wait. This is how we do it. Oh, thanks, doctor. You're sucking blood out of me with leeches. Brilliant. And we're going to say the same thing. Science continually changes as we gain knowledge. But if you censored truth, now we have a way to protect the nonsense from scrutiny and from real science. This is showing the methane myth. Methane drives climate. Methane, my dog could clear a room. Okay, his name is Duke. And Duke's a big dog. And when he lets out a little methane gas, yeah, it causes a major effect. I could go on a lot of stories. I'm only talking about flatulence. But when he lets one out, oh, man, and people are saying, get away. But methane's not driving climate, folks. It's just so minuscule. It's a non-player. 1 out of 500,000 pieces of atmosphere would be methane. Methane is 0.00017% of our atmosphere. Utter and complete nonsense to think for a second that you can save the world by putting one of those tubes on top of a cow to protect the world from climate change. We've gone too far. We've gone into utter, complete nonsense. Anthropogenic global warming is a hoax. I put that out there. I took these from Washington Times, New York Post, CNN, and so forth. Glacier National Park replaces signs saying glaciers gone by 2020. They were put there in 2000 or in that time frame. And we're looking at glaciers now. That's Glacier Bay right there, obviously. But the glaciers are still there. They're still doing strong. Matter of fact, there's more ice now than in 2015 because it's gone through a cycle. Climate is so dynamic. To think for a second that we can just emit a little bit of carbon dioxide to then cause radical change. It's an existential threat. Let's spend $300 billion to save the world. And it all comes back to their pocket, folks. Don't get me going on this. I'll start ripping now, man. When they start spending my money, every time I pay taxes, I'm thinking, all this money is gone already. I worked it, it's gone. It's corruptly given to other countries and to solve the problem, the existential threat of anthropogenic global warming, and it's your fault. So you need to eat bugs and drive a Tesla.
I was at Glacier in the fall of 2021, and they still had a sign up there saying that the glaciers would be gone by 2020. Yeah,
that's actually significant. They even left the sign there. Is like they're gone. Trust me, they're gone. No, really, they're gone. And it's like trust the science. Wait, science is skeptical. Science questions. It can also be falsifiable. You can sit there and take a picture and say, here it is. But no, you don't believe your eyes. Don't believe your lying eyes. It's real. And like I say, climate changes. And no one believes that climate changed more than me. And I throw that out there at first for everybody. It's like not even Al Gore, Bill Nye together, combined, don't even believe in it as much as I do. But I know for a fact that we have nothing to do with driving climate, especially with the scant trace amount of carbon dioxide there that we contribute, 4% of the world's carbon dioxide. Utter and complete nonsense.
Well, what has been your reception to your climate realism? Like, did you teach it in class at all? Or as you go around and talk in public, what reception do you get?
I get an amazing reception, actually. And you see, because I approach it on a scientific level, and most people, laymen, the only people that are against it have been completely brainwashed. It's like I showed them the paper by not Michael Mann, but the other guy. Anyway, the fellow John Cook. I showed him the paper. Here's John Cook's paper. You heard that Obama tweeted one day. That's all he had to do was tweet. Anthropogenic global warming is real because 97% of climate scientists say that it's real. Okay, so I actually pulled the paper up and read it. It doesn't even say that. There was basically a third. It was basically he took out of 20 years, if I remember correctly, over 20 years they took as many as they wanted, not all, because they didn't, they omitted some papers that could have been researched as well. But anyway, my point is this. It took 20,000 papers. They read the abstract only. They didn't judge the science, didn't do any evaluation, didn't see who funded it, didn't see who peer reviewed it. Oh, it's peer reviewed by a bunch of my mates. Yeah, and they all agree with me. So, hey, we peer reviewed it. We kind of massaged each other. We stroked each other. We said, good job. You made a amazing paper there, mate. So peer reviewed by who knows who. They didn't evaluate anything, but they took 20,000 papers, looked at the abstracts and said, okay, now how many of them say man-made global warming? So they had anthropogenic global warming. Yes. Anthropogenic global warming. No. Anthropogenic global warming. We don't know. It turns out about a third and a third and a third. Of the ones that believed in anthropogenic global warming, the third, which still wasn't evaluated, didn't judge the science. Guess what? Oh, 97% of them now. Oh, we took a number here. We kind of shuffle around. We, did the whole, smoke and mirrors. And then Obama tweets something. He never read it. He just told it. I'm sure he didn't read it, because if he actually read it, understood it, he wouldn't have tweeted it. I'll tell you that right now. So these things are a way we brainwash our people to believe, trust the science. I mean, I'll just be frank. If you think Fauci's science, he says, wait, you question me? I am science. I'm going forget about it. I was do the old, the mafia thing. Forget about it. It's crazy to say something like that, So the hoax of anthropogenic global warming, it gets summed up in a slide here. It's just look at the real statistics. Look at the thermodynamics of it. It's not poison. I had this one guy. He was a professor, a buddy of mine. I have lunch with him all the time. He said, if you put a drop of arsenic or strychnine in that cup of coffee there, it would kill you. It doesn't take much at all. And I said, I won't use his name, but I said, that's crazy. Me dying of this is biology. We're talking thermodynamics, the earth. We're talking physics. We're talking the first laws of thermodynamics. We're talking about movement of heat through a very dynamic and complex earth with volcanism and clouds, tilt. You can just go on and on and on. And I know most of your guests have talked about this. So I recommend that your mates and your friends that watch you go back and watch Harper and Lindzen and Curry and these other great folks that, when I was doing a talk, I said, I always give homework as a school teacher. I said, okay, well, do some research on the Volstock ice core samples and do some real honest research. You'll see that we had over 2 miles, about a mile, 2 miles deep of ice over at Volstock. It shows that we've had different times and in different eras, carbon dioxide in the atmosphere. There's a timeline like tree rings. Okay. We just do a core sample and say, okay, these bubbles here contain, a little bit of air. What's in it? Carbon dioxide. How much? Wow. We've had a lot more in the past. Now there's no label on. I'm saying this is during the medieval warming period. Well, we know this oceans warm, they degas. So as an El Nino comes, we get more water. We also get more carbon dioxide. So as the planet warms, and as things change constantly, it's so dynamic, you can't even keep up with it. So you look at the Volstock ice core samples, which show that we've had a fluctuation of carbon dioxide. The more carbon dioxide, as the founder of Greenpeace says, Patrick Moore, the better off we are. And I have to agree, just by, be teaching science for years, I know a little bit about botany. And botany is an amazing thing. Plants love it. And I mentioned about the greenhouses and so forth. The Milankovitch cycles of the sun and so forth in our orbits. I say, look at the founder of Weather Channel, John Coleman, the great John Coleman. I should send you a couple of his videos on my website. You maybe place them in the numbers here, because he does a couple good little jobs. I just said, okay, this guy's great. And he says, do I believe in climate change? Of course I do, but climate always changes, but we're not in a crisis mode. And then there's, of course, Patrick Moore, and then there's Susan Crawford or Crockford. You know who she is? I think you might have interviewed her. She's probably one of the world authority on polar bears. Well, she lost her job. She got sacked. Why? Because she went against the narrative. This guy takes a picture. He's waiting for days. Oh, we got a picture of a dying, this poor little, animals do die. They get old like we do. They don't have a funeral. They just go find a little place and die. So there's poor little polar bears going, oh, I'm going to die soon. And then he crawls up here and they take a picture of him. He's on his last leg. Climate change is killing him. You're driving a car. It's your fault, And so she says, I know, actually, this is a great time for polar bears. They're thriving. There's more polar bears than ever before. Why? Because there is warming. Because guess what? There's more phytoplankton in the water, in the oceans, because we have more sun and we have plants growing. And then we have, of course, more fish swimming. And then we have, more fish and we have more seals. Well, seals are the primary food of our friends, the polar bears. They're going, yes, bring on the climate change, bring on the warming period. This is what we like. Of course, she lost her job because she questioned the narrative. Okay. How about the guy, Peter Ridd? Peter, he's Australian, world authority on the Great Barrier Reef. Oh, no, the Barrier Reef. How does the Great Barrier Reef have any factor at all in climate change? I have no idea, but it's causing it. So he started publishing some stuff on it, and people realize this guy knows what he's talking about. Wait, fire him, sack that guy. He questioned the narrative. Get him out of here, censor him, because you're questioning our narrative that we need to spend your money to stop climate change. So there you go. I just paid my tax. I think things will be sorted out soon. We spent $300 billion last year, or 2021. So there, we could just toast to that. Crazy. Of course, there's William Harper, Friedman, Dyson. There's Willie Soon, Lindzen, Kim Ball, Tony Heller, Judith Kerr. Who is she? You think, Judith Curry. She was the chair of Georgia Tech technology, had to do with the physics and all that stuff. You probably know more about her than I do. But I do know one thing about her. She's a climate expert. And she is persona non grata now. Why? Because she dared question the narrative. Utter and complete nonsense. So unscientific, you can't even go there. And there's many more that have been censored or sacked or gotten rid of because why? They questioned the hoax that is giving them the justification to spend a lot of money. It's greed. It's the attack on actual capitalism, because if they can say, you got to stay in your house, you got to drive this, you got to, use public transportation, we're going to stack you and pack you up in these little apartments and make you into Hong Kong. I don't know if you've been to Hong Kong, but there's a lot of stack and pack there, and different other communist countries too, as well. They're not communists there, but they just got a lot of people, but they can confine them and quarantine them. And they tell you what, the conditions are terrible. I was going through Hong Kong. I couldn't believe. I traveled quite a bit around the world and seen a lot of things. And I'll tell you what, we do have it good here, but the current administration is completely gone. It's not even there. They are puppets of the radical climate change agenda, fear tactic. If you like say, don't let a crisis go to waste. Well, wait a minute. We need a crisis maybe we can create a crisis. Maybe we can fake a crisis. Let's see here. Climate change. It's your fault. Anthropogenic global warming is you. So now we could get rid of all the great things that our country has and attack people for their, you might say, their questioning, even questioning. I was over in Australia. There's a guy named Ian Plimer. And I don't know him well, but I've met him and we talked a little bit, and I should have got a picture with him because I was at a meeting with I'm not starstruck, but it's always nice to prove, hey, I was with Ian Plimer, and he goes on about the geology of the earth, and specifically how that geology, being the forensic study of the past, can give you lots of clues of this thing. And so he wrote a book called Not for Greenies or Not for Greens or something like that. Aussies are cheeky, and he says, check this out, Mike. And he talked about this. Matter of fact, he actually has a video on it. They have these subsidies in Spain. I think it was Spain, and they have the solar panels out. Well, they run them 24 hours a day. Now, how do you run solar panels 24 hours a day? We get generators, diesel-powered generators, churning up electricity so we could pour light on them at night. So we create the light with diesel, and then we blast it down on the solar panels so they can create energy, because guess what? They're getting subsidized for the energy they make. So it's, hey, we're making money, saving the world from climate change by burning diesel to create electricity with these inefficient solar panels. So my friend Ian, and I can say he's a friend, I'm acquaintance, but he was being very cheeky about this, and that he just annoys the heck out of these Aussies, especially the politicians, because he's a very well-known scientist in Adelaide, actually, where I used to live. And he was a professor of geology out there. But anyway, so like I said, I had a chance to meet with him and to chit chat, and I watched a couple of his videos, and I've seen him talk and so forth. And he just shows the lunacy of the green movement. So those are some things that I just have to bring out. So I leave this up here just for a moment. We have this red pill thing, and I show people we contribute 4% of that carbon dioxide. And there's so many more slides I can throw out there, but this is one that I've used too over the years. This is my first one I made, so this is a little nostalgic for me. This is the global warming reality check. Atmospheric composition of gas, excluding water vapor, which of course is the number one greenhouse gas. But just of our atmosphere, we have 2178, and most of that bit right there is argon. That scant bit, 0.038% carbon dioxide. Carbon dioxide levels are trace, and they're not driving climate. It's thermodynamic nonsense to think so. Let's just maybe wrap it up with the history of the ice ages. I'll name them out a little bit more. Around this is BC now, okay? So 2300 to 1600 BC, we had what they call the Great Ice Age. Now, these dates, some people may not buy into, but these are the ones that I've come to because we have certain evidence to show that. Now, the Mini Ice Age, now this is 600 to 300 BC. The Grecian Empire was during that Grecian Ice Age. And I mentioned that Alexander the Great didn't go north because it was just too cold. He had to go southerly and a little easterly to go conquer the world at the time. And of course, being Greek, I just got my plug in for the Greeks. I'm raised Greek, speak Greek, been to Greece. So I love Alexander the Great. Matter of fact, I'm hoping to go there this year for at least a couple weeks. So my Greek heritage was during one of those mini ice ages, the first mini ice age. And then we had the Roman warming period, which came after that. And then we had another ice age, and that was 600 to 850 AD. So that was after the Christ, or the Anno Domini. That was during the Dark Ages, okay? And then guess what happened after the Dark Age? We had the medieval warming period. And then around the Little Ice Age, started around 1400 BC to 1800, AD, 14 to 1800 AD. So those are some things to look at. And then things were happening on the planet at that time, specifically volcanism. We have all the dynamics of the sun changing and so forth, the orbit, the distance, the sunspots, the solar flares, and so forth. We could actually, there's been studies shown that during, the warming periods, that life on this planet thrived. And like I say, is primarily because there was more carbon dioxide, because carbon dioxide comes behind the heating. So as things warm, we get more carbon dioxide. And so as things warm up, we get carbon dioxide following. It doesn't lead the trajectory. It doesn't like, oh no, we got 16 parts per million contributed to the atmosphere. Oh, we're going to have a problem here because the temperatures, carbon dioxide is rising, and it's going to happen. It's going to follow behind with the heat. It's backwards. It's nonsense science. It's not even, you can falsify that, but they won't let you challenge the assumptions. I like to challenge assumptions. I think scientists have to challenge one's assumptions because those are the things that you can't really measure. I can measure heat. I can measure quantities. I can measure all these things. These are repeatable, observable, testable. But one's assumptions guide them to their conclusions. If I have false assumptions, I will have false conclusions. If I have false assumptions about the past and I'm kept ignorant about the past, then I have a massive problem of trying to understand my present because I have these delusions of what happened in the past. So I think, oh no, I got to start eating bugs. I got to eat Wonder Beef, or what's it called? Beyond Beef or Beyond Meat or whatever it's called, fake meat. It turns out that most of that stuff is GMO and bad for you. Well, of course it's GMO because Bill Gates is pushing it, and he's a big GMO guy. He owns 500,000 shares of Monsanto, and he's the number one farm landowner in America. No, there's not a problem there now, is it? I mean, you think about it for a second. You have Bill Gates, number one farm landowner in America, controlling shares of Monsanto. There's a problem there. You can GMO a seed. Now you patent it. Now we control the seed. Now, I was studying a little bit about Roundup and everything else. Well, you spray a field with Roundup, everything dies, including all the little animals, everything. I mean, you're killing a lot when you're using Roundup. But the plants are the GMO because they're designed to survive the onslaught of Roundup. So it's a cheap way to get rid of weeds and everything else. And I'll tell you what, those plants are pretty hardy. I mean, they made them pretty strong, but you're losing something too, because when you genetically modify something, you have to change it genetically. Thank you so much.
All right. Thanks a lot for being on this podcast, and I hope you can do it again sometime. Thank you.
I'd love to, and it's my pleasure. And Tom, thank you so much for what you're doing out there, red pilling.